Hello, sir. This is my assignment free presentation of forest fire prediction. My name is Chung Wei, and my ID is 104686750. And so the primary goal of our project is to develop predictive model that will assist in forecasting the burn area of forest fire by using meteorological data such as temperature, humidity, and wind speed. We aim to provide insight that will help firefighting agency, environmental organization, and policymakers to allocate resource more effectively and implement preventative measure. So by understanding how weather conditions like temperature and stuff contribute to fire severity, stakeholder can make informed decision about fire management. And first, it enable proactive risk management by predicting which area are at highest risk. Agency can allocate resources like fire personnel and equipment to those areas. Second, it improves cost efficiency as resources can be directed to where they are needed most. Third, early predictive can help protect the environment by allowing for target intervention strategies to minimize the spread of fire. Finally, these protection assists businesses in reducing insurance costs and managing risks related to fire hazard. So this is my overview of machine learning model use. In this project, we employ like 5 machine learning with 2 of the support for the ANN and KNN of humidities and temperature. This is burn areas. So I have ANN, which are excellent for capturing complex data patterns, random forest, unsample method that reduce overfitting and increase prediction accuracy. SVM, useful for classification tasks. K nearest neighbor, which is KNN, is a simple model but one that struggles with high dimensional data. And the last of all, decision tree, which provide intuitive explanation of variable importance in fire prediction. Okay, so we start exploring the data, which consists of 517 observations, with 13 variables, including weather data like temperature, winds, and humidity. In such and no missing value were detected, but we removed 4 duplicate record. Through correlation analysis and scatter plot, we identify significant relationship between key variables such as temperature, FFMC, and burn areas. And our analysis also highlighted data imbalance, which most fire being small, but a few major fires significantly influencing the dataset. To ensure the qualities of our model, we first remove duplicate record and retain outliers that present large fires, which are essential for accurate prediction. And then we go to the standardized key variables like temperature, wind, humidity to ensure that no single variable dominate the models. So yeah. Okay, so by using the correlation heat map, we are able to visualize the relationship between key meteorological variable and the burn areas, FFMC, DMC, DC, and temperature show strong positive correlation with the burn areas, confirming their importance in predicting fire spread and severities. So this one, I have adding the temperatures and the humidity burn area with the winds to support the wind stuff. So we explore the relationship between the burn areas, key wind speed, relative humidities and stuff. That this relationship highlight the critical roles of high temperature in intensifying forest fires. So the more temperature increase, the area burn tend to increase as well. Same thing with the speed, wind speed. The more wind speed, the less area burn. The more area burn, sorry. Sampling data. So this one. We kind of like split the 70% training data and 30% testing data. Was used based on the burn area, ensuring that both small and large fire was adequately represented in both dataset. This approach helped prevent bias and maintain the original data's distribution, reducing the risk of overfitting. And you see this is a create data partition function from the care package, was used to split, ensuring reproducing with the set seed. Yep, set seed. Okay. To build the predictive model, we developed 5 machine learning, the random forest, decision tree, SVM, ANN, and KNN. And for each model, like we perform cross-validation and the hyperparameter tuning to optimizing performance, and the R package like random forest, R part, and a net and class to build this model. Our approach to ensure that model were trained using robust method to avoid overfitting to improve generalization. The next one is one of the model we built was random forest. Did a sample method perform reasonably well but shown high error rate with an RMSE of 26.5 and an R-square of minus 8.59, indicating poor performance in predicting the burn area accuracy. Despite this limitation, random forest remained a powerful model due to its ability to handle complex data. And the next one is the decision tree stuff. The decision tree provide a clearer insight into the rule governing a fire spread, but it's also underperforming, particularly for larger fires. Its RMSE was 59.19 and it struggled with high error rates due to underfitting. However, the decision tree model remained valuable for explaining how specific variables like temperature and cold influence fire size. So the SVM, which had the lower RMSE than the decision tree and random forest model at 15.09, but still struggle with the variance explanation. Yeah, so some promise, but it's quite further turning to achieve better results. Yep, and for our best performance is the ANN, which achieved the lowest RMSE of 4.80. However, its R-square was still negative, indicating that the model struggled with capturing the full variabilities of the burn areas due to the data imbalance, and future iteration could improve its performance by addressing this limitation. So the KNN, which is simple to implement but perform poorly in its dataset. So yeah, no. Yeah. Here's the summary of our model performance. As showed, the ANN model achieved the lowest RMSE, had the best predictive accuracy through its struggle with variance explanation. So through the ANN model, our best performance, there's a room for improvement. So the key prediction such as FFMC and DMC and temperature play significant role in predicting fire severity. We recommend expanding the dataset to include additional features like vegetation type, land use, and implementing advanced resampling technique to address the data imbalance. Yeah, so the model we develop have practical implication for several key stakeholders like firefighting agency, environmental organization, and policymaker. To implement the model effectively, we recommend embedding it into real-time decision support system, expanding data collection effort, addressing the data imbalance through resampling technique, and training stakeholders to use the models inside continuously monitoring and retraining will be essential to maintain the model accuracy and reliabilities. So we are successfully develop and evaluate multiple models for predicting the fire burn areas of forest fire. The artificial neural network (ANN) performed the best, but there is more potential for further improvement through better data qualities and feature diversity. This model can play a vital role in helping agencies mitigate fire risks and protect communities and environments. So thank you for listening. That's all.